Welcome back, and in today's video lecture we want to talk about making our interaction with the putty window two-way. Right? So we're printing to the screen, but now if we'd like to tape on the keyboard, we'd like to get that information back. We want to make things a little more interactive. To do that, we're going to use functions from the plib library. The first one is getCUART2. And what that does is it simply gets one character, the C stands for character here, from the UART module. So the UART module has a little buffer. When you hit a key, that letter is held in this buffer and sets a flag. Okay? Now the trouble about getting that character is you never know when somebody's going to hit a key. If nobody's pressed and you get a character, you're not going to get anything. So you need to wait for somebody to have pressed a key. And we're going to use this function right here, the while not data ready UART2. Okay, data ready UART2 is the plib function, and it simply says, has somebody pressed a key? And in terms of the module, it's looking to see if something's saved to the buffer. Okay, buffer is just a small piece of memory used to hold any keystrokes. It'll disappear if you start pressing other keys, right? So a while loop simply waits and polls the status of this guy. Let's have a look at the plib library, the function, and here we have press a key and a greater than symbol. The greater than symbol comes from here. I added it in. Greater thans are very common in terminal programs to show that the program is expecting some keyboard input from you. So call this back up. I'm going to hit any key. It says I typed the letter F. I put braces around it, which is ASCII 102. So perfect. There's no problem getting a character from the keyboard. Okay, now just want to go back and talk to you about while loops again. While loops wait, but while loops let you do other things while you're waiting. So if I came here and put in some curly braces, okay, I could do something else. What could I do? Well, we don't know how to do too much other than put in text, so I'm just going to put in a text message. And there's a question mark and a greater than sign, so it's sort of going to be a little hurry up, hurry up. So let's build that, see what happens. Starting to build. Build successful. Connecting to the programmer. Almost loaded. Get the putty window back up. Oh, and now you can see, right? While it's waiting, it keeps printing out this prompt. Could get annoying, but let's just hit a key. Okay, there, and it stopped. So when we use this while setup, okay, we can do other things. Quite often you'll just see me using it like this. And that's okay, right? But we could do other things. Okay, the next thing we want to look at is this piece of code right here. It says press carriage return, CR, or the enter key to continue. And then I have this function wait for enter. Wait for enter is something I've written and put into the configure UART window. When you're using terminal programs and you want to interact, it's a good idea to have something that lets you stop the programming and wait for the user to continue. Okay, so all it is, if we look at this function right here, go into the library, find wait for enter, all it does is this waits on the UART, and then it gets character, and it waits while it's character 13. That's all it's going to wait for, character 13. Any other character it ignores. So it's just, you have to hit the enter key if you want to move on. Let's try that. See if you can. Right, so I'm typing a whole bunch of other keys. Nothing's happening. Now I hit the enter key and it goes. It's just a useful way to split up these programs. Slow down what's being printed. Wait for the user to catch up with the program. So now what we want to do is get continuous single character input from the keyboard. You might think all we do is take the code and put it inside the while one loop, and that's pretty much what we could do. But what we want to do is to be able to do other things when we, besides just getting the key press. So instead of having while one not data ready get USART, since we're already in a continuous time loop and it's going and going and going, we certainly don't need another time loop, so, or while loop. So instead, since we're already always checking this, just do an if statement. There's no longer a not in front of the data ready UART2. We're just saying, is there something to be read? And if there is something to be read, then just get that key press. We also have a bunch of statements that we can see what type of letter that is. Okay? That's all inside an if loop. If there is no data waiting, then this is outside that if statement. It does all of this stuff, and this will be a little more obvious that it's a little animation. So I'm going to go back to the C code, and so that we can see what's happening. Going back to PuTTY to see what's happening. So when I press continue, you'll see that I've got a poor man's animation here. It says it's waiting for input, right? So it's going and going and going. If I type a letter, it tells me the ASCII code and the symbol, and also that it's lowercase. But this little animation keeps running. If I had a while inside of a while loop, I couldn't do that. I want to be able to do other things while I'm waiting for character input. And many of the projects I'll be asking you to do, I'll want you to do other things. So this is how we will do that. So let's just go back to the code again. In the code, instead of a while, it's an if data ready UART2. And inside the if statements, it's a get C UART2. Just to mention a little bit about the animation, this symbol here, /B, that's a backspace. So every time I print a symbol, this moves back one and prints over that. So it overwrites the previous statement. Also, if I want a backslash as just a backslash, I actually need to use \\. Right? because we're using backslash for these escape codes or control codes. So this is the little animation. This is just a little function to wait 80 milliseconds. We don't have to worry too much about that right now. We'll be talking more about delays in other parts of the code, on other days. Okay, inside the if statement, after we get the character, it tells us the ASCII code number and what this symbol is. And it only does that if it's a printing character. Right? Any of the characters below 32 don't have a symbol. Okay? In here, we're also using a bunch of functions. This is from one of the libraries, and we'll talk about that libraries later. This is upper, checks if the character is uppercase, lowercase, is it a digit, is it a control character, is it punctuation, is it a space. These and many other functions are in a library called ctype.h, which we'll talk about next. So we're working with single characters, and one of the C libraries that's really helpful when you're working with characters is this one, ctype.h, which I've listed in Appendix I of the course manual. Here are the functions that you should know about and be reasonably familiar with. These functions ask things like, is the character alphabetic? Is it from either capital A to capital Z or lowercase a to Z? Is it one of the ASCII characters? Right? Is it a digit? Right? Is it lowercase? Is it a printing character? Is it a graphing character? Punctuation? All these possibilities. Okay? These are quite useful for you to know, and particularly in some of the projects we're doing, you'll be wanting to check if something is uppercase or lowercase. Also, in this library, there's a couple of other useful functions. It, for instance, toUpper takes a lowercase or an uppercase symbol and returns the uppercase version of it. So if you gave it lowercase a, it would return uppercase a. And the opposite or inverse function would take something like a capital A and return a lowercase a. Those are really useful functions anytime you're working with single characters. Bye for now.